Hey guys, Sluggernaut here. I just wanted to do a quick video on the static keyword. I was in an interview today and was asked what static means or how the static keyword is used, and I just could not think of how. I started describing immediately something, and the guy stopped me and said, "Are you describing const?" And I said, "Yes." And he said, "So what is static then?" And I said, "I don't know," because I was so nervous I just couldn't think of what static was. You can see where my head was at. Static, immutable as opposed to dynamic. So const, right? No. I mean, those are completely different keywords. So just to sort of help myself and help everybody else, I whipped out my test console program where I've already got some stuff going where I'm printing things to the console, just the size of shorts and ints and longs and floats and doubles, etc. And this is sort of a study thing for myself that I was kind of messing around with. Anyway, I figured I'd throw in a class called cstatic1 and make some variables, one of which was static, and of course I also have a static, a couple of static functions here, member functions, and sort of show off what static is. Sometimes people ask about a static class or talk about a static class. You can actually put static in front of the class declaration and it won't do anything. Visual Studio's, the compiler doesn't care. It might give you a warning, ignored static, left of cstatic1 when no variable is declared. This means nothing. I think there used to be a use for this for templating or something. It was like an old type of, it was an old keyword. But I can't remember, I'm not sure. I just will tell you that it does nothing, making a static. So static, let's get on to what static does then. So I have a static integer. I've made it public for various reasons, and we can go over that in the video. I have a static integer called x. I have a static method called getInstance for later on, and we have a static const char thing here. So let's just concentrate on the variable. So the variable is here. Static means that every instance of this class is going to share the same memory address and the same variable. It's not going to be a copy and keep getting copied over. It is going to be the exact same memory address, and we're going to prove that later on. All of the instances of the object are going to share that address for that variable. So to initialize this, I've just said so you just scope it in like this, cstatic1 : x. So we've scoped it in, and I've made it 3. And then every time a new instance of the class is made, a new object is made, we are going to add one to that. So we can see right off the bat, if you were looking and sharp-eyed before, all I did was say cout, and I scoped it in again. So you can see how this is sort of a global variable now. I'm just scoping in cstatic1 : x, and we get, of course, that it is 3. And then all I'm doing is creating an instance of cstatic1 in the form of calling it a. So now we have our a object, which is a cstatic1 object. So now we are going to use our, so let's go back. So all we did was create a, and bam, we've got, it is 4. So we haven't actually changed it manually from here. You can see that that's happening from within the CPP here. So what else can static do? I had another one here. So this allows us to do that. So static, so it should be 3, 4, 5. Yes, 3, 4, 5. Now, that got me thinking, well, I mean, I know that so that got me thinking, I know that they share the data member, but what is the size of one of these variables, C static 1A or B. Don't forget that we have one private data member here that we're never using, but it's here just for certain purposes, and we'll see that in a minute. So we have a private data member. So is the size of a C static 1 the size of 1 int or 2 ints? Let's find out. This is probably something I learned back in PG2 at Full Sail, but I can't remember. It's been so long since I really looked at the details of static. I did know that static is something that helps you sort of share memory among several instances of the same class, or in the case of, so we're going to doing get address. In the case of get address or get chars, which is just returning a const char pointer and returning that text, that helps us have sort of a helper class. I'm going to go over one more reason that we would have that in the future. So now we're saying a.getX, and we're outing the actual thing here, the actual getX here. So it should be 3455, right? So we out it in the beginning, and it starts as 3, and it tells us it's 3. We make 1, we out again 4, we out again 5, and we go back and look at a.getX, and we see that it is still 5. So what are we doing after that? And this is what I wanted to know. I looked at the address of A and the address of B just to see where those are. So these are at this address in memory. Then I made this a.getAddress and b.getAddress. And this is actually returning the address of x, our static integer. So both of these, now we can see, are located here, and they are 29F9E4, 29FA04, right? So these are two totally different variables, A and B. Now, what happens when we look at the address of x for each of them? Of course, it is the same address. No surprises there, really. They should be sharing the memory address of that variable. It should be exactly the same. This is exactly, now this is an example of what static is really doing behind the scenes. I was kind of messing around with memset. So what I was doing is saying, well, what if I memset all of A, size of A, to 0? Is that going to memset the static variable? Because it's not within the memory address of, it is not within the memory address of A. It's not contained in A in the same way. Usually when you zero out an object like this, it's going to zero everything that it contains, every variable it contains, I should say. So what happens? So we compile it, we look, 3455, these are our addresses where we left off last. Our memset should be right here. Actually, let's do a so now we know where our memset's at. Scroll up, memset. So we should have memset everything to 0 right here, and in a normal usage, we would see that this is 0, but again, I don't know why I'm outputting these addresses again. So every time the code is reran, by the way, we're going to get different addresses here. So these addresses shouldn't be the same as the last time we looked. So memset, we set it to 0, negative. That did not happen. And we can see again that, yeah, this is way outside the data here. So the last thing I did was look at size of A, and if A is the size of 2 integers, as we saw here, we have a static int and a standard int. If we look again, you can see that the size of A, which is this guy right here, this 4, is the size of 1 integer. And again, there's no surprises here. So really, this just, again, is an example. We're trying to exemplify what is static doing exactly. Last thing, I wanted to just show you how the static, so you can see that the getX address is being used as an actual function call from a class object. Even though it's static, we can still call it like that. Static const char get chars. What if I didn't actually have an instance of the object? The reason you would make a static function is to just be able to say static one scope get chars, and just like we scoped in this ::x up here to actually get the direct variable that is the static data member, we are now scoping in the function, and it should say something along the lines of this is a static func text, because that's what we made it say. So the last thing I wanted to go over was a static class. Usually when I have heard people say they want a static class, they mean a singleton. How does a singleton work? A singleton, it works in a way where you are telling the class you want the static instance of the class. So we want to make sure that this class, actually we'll make this one right here, is the only instance of the class we could ever have, right? So how do we do that? Let's just get rid of all this junk. Go to our CPP. We don't need that. So we're done with static variables for now. We want, again, a static class or a singleton. So we are going to say, let's see if I can do this from memory. getInstance. Whoop, we need a return on there. I think we want a cstatic1 pointer. Now, let's get rid of this other thing. We'll just leave the int y in there. So, whoops, getInstance. Shoot, I forgot we need a reference to ourselves. I might have to go look this up. So the main idea is that we check to see if scope that in. So we make it a null pointer off the bat. If somebody is calling getInstance, we say if instance return instance. Why doesn't that work? See in a second. New why doesn't it like instance here? Non-static. What did I forget? So the point is, the main thing that we want to accomplish, and we're going to go look at some old code in a second and see how I used to do this. If the instance has already been created, then return, we are returning ourselves. Otherwise, make a new. And the last thing we have to do to keep people from just going ahead and creating any version that we want, let's get rid of all this. Creating several instances. So right now we could. Nothing stops us from making more than one instance. What if we just called, the thing? What if we just called it? And created one like normal. Well, all you have to do is make the make any constructor private. So now we can't construct a new instance by ourselves. I think I typically take the destructor as well, and in the destructor's code we actually delete instance. What did I forget though? So somehow instance isn't available in our getInstance. And then you can add whatever code you want, and you treat it just like a normal object, and everything is fun and great, and you cannot have more than one instance of this object. I am told through Full Sail at the very beginning of Final Project, so at the very end of all of Full Sail, they told us this is not a good coding practice. You will never see this in a professional environment. Do not use this. All of a sudden, which was kind of annoying because we'd been using it a lot as students. We thought this was a really good, nice way to handle classes sometimes. But it turns out it's not. So what we are going to do, I actually went and did a lot of research on singletons, static classes, static members, everything I could think of, and try and figure out like what was a static class, and it turns out it's just nothing. It's pretty odd. We are going to go look at my, we get a peek at my server, and let's go take a look at copyright infringement. What is this? Oh goodness. So final turn in, and I'll probably cut a lot of this out. Oh, installer. I don't want the installer. I want everything. So, Dvorak's gonna kill me one day. I made my input class a singleton. I asked the teacher, is there any actual, major reason I should really completely avoid singletons throughout all of Final Project? Is there any benefit to that? And he said no. So I was making a class here that would read all of our input and track it and everything. And so we can see that, yeah, this returns a C input pointer. We called it getInstance because we just love that sort of thing. Okay, I said static C input instance, return instance here. And in the header, we had, is that it? Is that all I did? That is so annoying. So let's go back, take a look. All right, so let's comment this out for now. Oh man, that is so embarrassing. I can't believe I forgot how to do this. Oh, I have. So it works. It works now. You should be wondering what the hell an instance is. So oh. What? So. Oh. All right. Well, this has been a good review for me, obviously. Let's just go back and double check. Yeah, we never needed a private data member or public data member for that matter. All you need is this. All you need is love. All you need is this. So within getInstance, we are creating a static variable called instance and returning that address every time. So anybody who comes in here, this doesn't seem right. For some reason, I feel like this just isn't right. Okay, well, I'm just going to cut it for today. Hope you guys learned something. I know I did. I'll catch you guys.